Okay, so let's go through this kinematics question. Question 5. A particle traveling in a straight line passes through a fixed point O with a speed of 2 meter per second. So meaning that at time equal to 0, right? So time equal to 0 second, the particle move at 2 meter per second. So the acceleration is given as the equation, right? A equal to negative 2e negative 0.5 t. The particle comes to a instantaneous rest at point P, meaning that at point P, I stop. So V equal to 0. Okay, but I show that the particle reaches P when time equal to k ln half. K is an integer. Okay, so first, based on this information, right, we are given the acceleration time equation. What I need to do is actually to get your speed or velocity time equation by integrating. So V is equal to integrate of A dt. Then after that, right, you integrate negative 2e negative 0.5 t dt. So after that, you just integrate lah normally. So negative 0.5 t divide by negative 0.5 plus c. Always remember to plus the c. So it's equal to 4e negative 0.5 t plus c. Okay, so that's the speed time equation. But I need to give them the c also, because c is a constant to be determined, right? Okay, so this is where this thing comes in already. A speed of 2 meter per second when I pass through fixed point O. Always remember, when you pass through fixed point O, for this particular question is time equal to 0. So time equal to 0 second, your speed is equal to 2 meter per second. So meaning that this part you put 2, this part you put 0. So 2 is equal to 4, e to the power 0 is just 1, right? Plus c. So c is equal to negative 2. Okay, based on this idea, I can already almost want to solve already, right? Okay, so they say that, show that the time is as such when I reach P. So when you reach P, you actually undergo something called the instantaneous rest. So V is equal to 0. So based on the velocity time equation, so V equal to 4e negative 0.5 t minus 2. So when you undergo instantaneous rest, 0 here. But I want to solve for t. So this one back to a bit of your logarithm already. So okay, so first so this is 2 because you move the negative 2 to the left hand side. 4e negative 0.5 t. So move the 4 to the left hand side. Half equal to e negative 0.5 t. Then you of course you just ln both sides. So ln half equal to ln, so I just apply the power law. So ln e negative 0.5 t. Move the power down. So ln half equal to ln e. So ln e itself is just 1. So you just need to times negative 2. Okay, so this one, okay, this one. Okay, then you times negative 2 throughout, you will get negative 2 ln half is equal to positive 1t. So in this case, you already solved the time equation already. So the k to be determined, right, is actually negative 2. Okay, so now let's move on to part 2. Calculate the distance OP. Okay, let me just draw this thing first. So 0 meter, so this point P. So time equal to 0 second, you are at 0. When time is equal to negative 2 ln half, you are at point P. So how do I calculate what is the distance here? This is where you need to get your displacement time equation by integrating again your velocity time equation. So let's integrate let me just write here. So how do I get the displacement? I simply just integrate one more time. So integrate V dt. So you integrate what is your V? So V is 4e. Okay, so this is 4 0.5 t minus 2 dt. Okay, So 0.5, good. Okay, so next part, you simply just integrate term by term. So 4e negative 0.5t over negative 0.5, then after that minus 2t plus c. So what you get is negative 8e negative 0.5t minus 2t plus c. So that will be your displacement time equation. Of course, before we can solve the question, right, we need to find what is your c, the constant, right? Okay, this is where the first part comes in already. Not say the first part, the thing, right? The fixed point O. Now, when I pass through fixed point O, my time is equal to 0, meaning that when displacement is equal to 0, my time is equal to 0 also. So I simply, based on this idea, I sub inside to find what is my C. So this is 0, this is 0, this is 0. So what I will get is 0 equal to negative 8. E to the power 0 is just 1. Minus 0 plus C. So your C is just equal to positive 8. Yeah, so okay, the full displacement time equation is equal to negative 8e negative 0.5t minus 2t plus 8. That will be the displacement time equation. Okay, so they want us to calculate what is the exact distance of OP. So we know that at P, right? Okay, so let me just draw the thing again, right? So 0 meter, point P. This is time equal to 0 second. Your time here is equal to negative 2 ln half. Based on this idea, I can just simply sub in, because I just need to sub in that time is equal to negative 2 ln half into the equation as given, as found by me, right? So let's find. So S is equal to negative 8e negative 0.5 negative 2 ln half bracket minus 2 negative 2 ln half bracket plus 8. So it's equal to, okay, so I just manipulate fast one. So negative 8e ln half, then plus 4 ln half plus 8. So that's the answer. Of course, e to the power of ln half is just half. So you'll get negative 4 plus 4 ln half plus 8. So you'll get something like 4 plus 4 ln half. Then just put your calculator. I assume they don't want the exact form. If they want the exact form, they must say that, find in exact form. So since they never say, I just put them in 3SF, which is 1.23 meter. So this 1.23 means that from O all the way to P, right, is roughly 1.23 meter. Okay, now after solving this question, let's move on to the next one. Okay, this one is a bit challenging. Show that the particle is again at O at some instant during the, so the keyword is actually this, 4th second after first passing through O. Okay, what do they mean by the 4th second? This means that from the third to, from 3 second to 4 second, right, there is a particular moment in time where you are at 0. But we do not need to tell them what is the exact timing. We just need to show. So between 3 and the 4th second, you will be at O. Okay, so how do I solve? Same idea, I need to make use of the displacement time equation, right? So displacement is equal to, okay, let me just go back here. Negative 8 e negative 0.5t minus 2t plus 8. Okay, minus 2t plus 8. Okay, so let me just sub in 3 first. Meaning that, okay, let's sub in time equal to 3 seconds. So, okay, let's see where I am. So, negative 8e. Okay, so negative 0.5 times 3 is just negative 1.5 minus 2 bracket 3 plus 8. So, what you will get is negative 8e 1.5. Then minus 6 plus 8 is plus 2. Okay, so let me just calculate. Okay, so at time equal to 3 seconds, you are roughly at 0.215 meter. So this 0.215 is not the distance you traveled. It just means it's like GPS like that. So you are at 0 meter. Okay, so this is 1 meter. Okay, so at 3 seconds, you will be at roughly here. So this is 0.215 meter. This is at 3 seconds. Okay, let's determine where you are at 4th second. So let's sub in. I put here. Okay, sub in 4. So T sub T equal to 4 seconds. So S is equal to negative 8 E. Okay, so 4th is negative 2 minus 2 bracket 4 plus 8. So you can see, right, this part is 0 already. So it's equal to negative 8 over E squared. Okay, let's see where I am at 4 seconds. Okay, so I'm at negative 1.08 meter. So let's draw on the so-called the path. So negative 1.08, since it's negative, means it's on the left-hand side of the 0 mark. So this is negative 1. This is negative, okay, so I roughly right here. So negative 1.08 meter. So this is at 3 seconds. This is at 4 seconds. So meaning that from 3 to 4, between 3 to 4 seconds, there is a particular moment in time you need to be at 0. Because how do you go from 0.215 meter to negative 1.08 meter without passing through the 0 meter? That's not possible, right? So at some particular moment in time, you must pass through 0 meter. So that's how you solve. So that is the meaning of throwing. So for this, they are not asking you to find what is the time. What is the time taken, the second timing that you are at 0 meter mark? No. So you just need to explain in terms of a bit of word. So since at time equal to 3 seconds, particle is at 0.215 meter. At 4 seconds, particle is at negative 1.08 meter. So this means that it will need to pass through 0 meter at some point, at some instant between 3 to 4 seconds. That's it. So that's how you do the explanation. Alright, so I think for part 3, the important keyword is actually the 4th second. Always remember, every time you see 4th second, you will need to know, it's from 3rd to the 4th. Or if they say 5th second, 5th is from 4th to the 5 second. So that's the meaning of this question.